In this video, we're going to talk about an example of how to calculate the expected value of the sample mean and the variance of sample mean. So first, let's recall the example we talked about before. Let's see here. So that was the house unit example. We had 3 units, and of each unit has either one of them has 2 apartments, the second one has 3, and the third one has 4. And a simplified model is simply that you have 3 numbers. One is 2, the other is one of them is 2, the second one is 3, and the third one is 4. So if you put these 3 numbers written on a piece of paper and put them in a box, and you try to draw 2 numbers randomly, but when you draw the numbers, you draw a number, you put a number back, and you draw it again. So that's a sample of size 2. But of course, if you say, can I do a size 3, size 4, size 5, you can do it, because you just take one number, record a number, and put a number back, and draw another one, and record a number, and draw another one, record a number, and draw another one, record a number. So because every time when you draw a number, you put a number back, so you can get a sample size of any size. Okay, so we go back to you can see here, in this example we did a sample size 2. So if you look at each column, this 2 2, we draw 2 numbers, and 2 3, 2 numbers, so each of them has size 2. But of course, if you draw 3 times, you may have 2 2 2, or 2 2 3, or 2 2 4, or 2 3 4. So it could be anything. You can make the sample size 4, or you can make even the sample size like 36, like in the homework. So for the sample size 2, because this is easy to calculate, so we did average, which is this second row here, and if we want to find the expected value of x bar, we use the formula. We can use the formula, and first thing we did was that we want to find out the sampling distribution, as explained before, of x bar. So sampling distribution is talking about, whenever we talk about distribution, we're talking about the probability of each number. So we have different numbers. We have a number 2, we have 2.5, we have 3, and we have 4. So you would do 2. How many 2's out of these 9 numbers? We only have 1, so which is 1 out of 9. Let me see where my table was. Let's go check. So this is the probability distribution of x bar, which is also called sample distribution of x bar. So you can see 2 is 1 out of 9, and 2.5, the 2 numbers, 2 out of 9, 3 out of 9, and 3.5, 2 out of 9, and 4 is 1 out of 9. But there's a different way to calculate. Instead of doing counting how many 2's, or how many 2.5's, how many 3's, we can use the property of probability. For example, I can because we have 3 numbers, there's only 1 2, so that when you draw one number from the box, the chance of getting a number 2 is 1/3, because there's only one number 2. So 2 3 4, 1 out of 3, so it's 1/3. So that's what I have here, P of 2, which means when you draw a number, you want to draw a number 2 from the box, that chance is 1/3. And the second, and then you put a number back, and you want to draw a number 2 from the box again, the chance is again is 1/3. So if you just randomly take a number out of the box, it could be any number, but the chance of getting a 2 is 1/3. So the first number, if you want to get a 2, the chance is only 1/3. The second number is also 1/3. When you multiply them, you get 1/9, because these 2 drawings are independent. They're not going to affect each other. So it's 1/3 times 1/3, which is 1 over 9. And that's that matches the number we had before, because 2, if you want to get average 2, that's 1 out of 9. It's the same as 1/3 times 1/3, which is 1 of 9. And similarly, when we do the average 2.5, we know that we have two numbers, so 2.5 here, 2.5 here. And how do we use probability to do it? Because we can do, say, what's the probability of getting 2, 3? So first, when you draw the first number, the chance of getting a 2 is 1/3. And then you put a 2 back, and then you still have 3 numbers in the box, and you want to draw number 3, the chance is still 1/3. So 1/3 times 1/3 is 1/9. So here, the probability of getting a 2 times probability of getting a 3, it's 1/3 times 1/3, it's 1/9. But there's another way to get an average 2.5, because you can also get numbers 3, 2. So again, you do it again. So number 3, what's the chance of getting a 3 when you draw a number from the box? It's 1/3. So, and what's the chance of getting a 2 from the box? It's again 1/3, because every time we draw a number, we put a number back. So it's 1/3 times 1/3, it's 1/9. And for these two cases, 2, 3 and 3, 2, 2, 3 and 3, 2, you both get at the same average 2.5. So you're going to add these two probabilities, 1/9 plus 1/9, that's the 2/9, and that is the probability for getting an average 2.5, which is the same as 2 numbers. You have 2.5 out of 9 numbers, so which matches this. So again, you can do the same thing for 3. So how many 3s you can have? 3 out of 9, but you can also use probability. So what's the probability of getting a 2, 4? It's 1/3 times 1/3, it's 1/9. What's the probability of getting 3, 3? It's 1/3 times 1/3, it's 1/9. And then what's the probability of getting a 4, 2? 1/9, 1/3 times 1/3 is 1/9. So you add all these 3 1/9, you get 3/9. And the same for 3.5, the same for 4.4. So that's a different way. But apparently for this problem, you can just count how many 2s you have, how many 2.5s you have out of 9. That's much easier instead of doing this way. But some of the problems you have to do it this way, because it's, for example, if I change the numbers, suppose in the box you have, there are 5 pieces of paper, and 2 of them were written had a 2 on it, and one piece of paper has 3 on it, and the 2 pieces of paper have 4 on it. Okay, so in this case, you draw a number from the box. You have 5 numbers in there, and there are 2 2s, 1 3, and 2 4s. The chance of getting a 2 is going to be 2/5, not going to be the same as before, because the example before you have only like 3 numbers, 2, 3, 4, and like if you look the house example right here, so you draw a number out of here, the chance of getting a 2 is 1/3, the chance of getting a 4 is 1/3, the chance of getting a 3 is also 1/3. But in our case, I didn't draw the houses. In this example, I just have 5 numbers, but there are 2 2s and 1 3 and 2 4. So in this case, the chance of getting a 2 is 2/5, chance of getting 3 is 1/5, 1 out of 5, chance of getting a 4 is also 2 out of 5. So you can change it into decimals. It's a little easier to calculate them fractions. Okay, so we write down the distribution, but this is the population distribution. For 2, it's 0.5, for 3, it's 0.2, for 4, it's 0.4. Copy numbers from here, and then we're gonna try to figure out we're gonna do a sample. So we're gonna pick 2 numbers out of suppose we're gonna pick 2 numbers, the sample size is 2, from these 5 numbers. Again, always remember, when you pick the number, you will put a number back after you pick it. So we do 2 2, and this time we cannot so you find out averages 2, and the averages for 2 3 is these will be the same as before, but you cannot do, okay, there are 1 2 out of 9 numbers, so we cannot do it like this anymore, because the chance of getting a 2 is different from the chance of getting a 3. So when we calculate, we actually have to use the second way. So what is the chance of getting a number 2 and a 2? So by what we learned before, so we would say, what's the chance of getting the first 2? It's 0.4. And then we put a 2 back, and then we draw the number again. What's the chance of getting another 2? It's still 0.4. And because, there are 2 numbers out of 5 numbers are 2s. So you will multiply 0.4 and 0.4, you get a 0.16. So that's the probability. So 60% of chance you will get a 2 at the first time, another 2 at the second time. So similarly, you can find the probability for the rest of them. So I put a 0.16 here. I did 3 of them. So 2, 3. What's the chance of getting 2, 3? So, and then you do, what's the chance of getting a 2? 0.4. What's the chance of getting a 3? 0.2. So I do 0.4 times 0.2. That's 0.08. I write that down here. And then do next 1, 2, 4. What's the chance of getting a 2, which is 0.4 from the table? What's the chance of getting a 4? It's 0.4 from the table. So we multiply then get a 0.16. In the homework 7.7, they already gave you the distribution table. So this table is given, and you don't have to calculate the probability like I did here. So because they give you that what the probability of getting a 0 is 0.3, the probability of getting 1 is 0.4, probability of getting 2 is 0.3 in homework 7.17. So we did all of this. Follow my example, calculate all of that. Just multiply the probability of the first number and the probability of the second number, and then we're gonna try to find out so that's the how we do the first part A. You will find out the probability distribution for x bar. Okay, so we're gonna make a table for x bar, because x bar we have different values, 4 different 2, 3, 2, 2.5, 3, 3.5, and 4, 5 different values. So we're gonna make a list of those values. Wait a second. Okay, so for x bar, so I've copied the table right here. That's what we calculated before, and we put in here. We have value 2. For value 2, there's only one probability corresponding to it, so 0.16. So I copy it. What's the probability of 2.5? There's a 2.5 here, and there's a 2.5 here. So we gotta add these two numbers, 0.06, 0.08. We add in 0.16 because there's a how do we get this average 2.5? When we draw a number 2 and a 3, and the probability of getting a 2 at the first time and a 3 at the second time is 8%. And also you may get a number how do we get another 2.5? Also, you may draw a 3 at the first time and a 2 at the second time. And what's the probability of getting a 3 at the first and 2 at the second? It's also 8%. So, but these two are two different ways. So we got to add these two. 8% chance of getting a 2, 3, and 8% of chance of getting a 3, 2. And then together we got a 16% chance of getting an average 2.5. So it doesn't matter if it's 2, 3 or 3, 2. The average is always 2.5. So in both cases, you always get average 2.5. So the probability of getting a 2.5 is the chance of getting an average 2.5 for your sample is 0.16, which is 16%. Similarly, we can look at the 3. So what's the probability of getting a average 3 for your sample? So when you pick two numbers, what's the chance of the average equal to 3? So we actually have 3 cases. You may have 2, 4, or 3, 3, 3, or 4, 2, and you calculate. We already calculated the probability for each one, 0.16 and 0.04 and 0.116, and you add these 3, so you get 36%. And then similarly, you would do the same thing for 3.5. So you have 3.5 here, 3.5 here. So either you get a sample 3, 4 or sample 4, 3. You will always get the average of 3.5. So the probability of getting an average of 3.5 for your sample is 0.08 plus 0.08, that's 0.16. So 16% of chance for your sample is your average is 3.5. And for the average of 4, there's only one way, that's 16%. So there's a 16% chance of you getting an average 4 for your sample. So this is called the probability distribution table. So that's for part A.